Developing a VR simulator for robotic navigation and human-robot interaction employing digital twins. This work was presented at the 29th IEEE Conference on Virtual Reality and 3D User Interfaces, Australia 2022. Providing high-quality care to seniors and adults with developmental disabilities present challenges associated with personalized care as a result of the high variability of conditions within the population. As the percentage of seniors grows worldwide, new technologies and processes are being created to provide care to this population. However, research and development currently face challenges created by the COVID-19 pandemic and the limited resources to which many long-term care facilities have access. Some emerging technologies that can improve the quality of care during a pandemic are being explored, including service robots, virtual reality, and artificial intelligence. That's why the Ether robot was created in a collaboration with the Developmental Disabilities Association, or DDA. Ether is a socially assistive robot designed to help seniors and people living with developmental disabilities achieve more independence and to alleviate the burden of care for caregivers. The main use cases identified with DDA are safety inspection, where the robot searches for safety hazards or fallen people, and entertainment, where it performs cognitive stimulation activities. Research and development associated with service robots have faced a major disruption due to the limited access to long-term care facilities imposed by COVID-19 restrictions. Such a limitation hinders the field testing of robot skills in the environment the robot will be deployed. A solution to this problem is the use of simulation. Tools such as the Robot Operating System and Gazebo allow performing simulations to test and fine-tune the robot's performance. Although simulations are possible with Gazebo, the lack of virtual reality components make it difficult for people with no technical backgrounds to participate in the design process. The access limitation also forced us to rely only on open datasets to train the human-robot interactions and fall detection. These datasets are usually not representative of the elderly and do not contain images of natural falls. To overcome these challenges and to further advance the development of service robots, we build on previous work prototyping a VR simulation environment for virtual service robot testing. The simulator provides means to test navigation and human-robot interaction. Users can enter the virtual environment to interact with the virtual robot by controlling avatars using a VR headset. We also created a new virtual environment that replicates a space to which we currently have access. And finally, we used the simulation to tune the robot's navigation stack. The simulator also enables the generation of synthetic data for training machine learning models. Synthetic data allows the creation of annotated images that closely represent the real world. They also help overcome the challenges of collecting data and the privacy and ethical issues that can limit the sharing of datasets. In this work, we created three main digital twins. Firstly, the route to be navigated, which is a replica of the office space at JTQ Systems in Vancouver. Secondly, the virtual ether, which includes a replica of its mobile base, camera, LiDAR, and inertial measurement unit. And thirdly, the elderly avatar that can be either animated or controlled by the user using a VR headset. Our proposed system has a server computer, which runs the simulator within Unity and communicates with the Oculus Quest 2 and the robot computer. The robot computer runs the Robot Operating System, or ROS, and the robot software stack that includes control, perception, and all the other modules the robot needs. This architecture prevents CPU bottlenecks and ensures that the robot will have the same performance in the real world. My ether,
I am listening.
go to the living room.
Would you like me to go to the living room?
Yes.
Going to the living room.
My ether,
Ether is ready.
who do you see?
I am looking at Jessica.
To evaluate the simulator's ability to navigate a virtual environment and detect virtual elderly falls, the virtual service robot was placed inside a replica of JDQ's office space used for real-world testing. The cartographer software was instructed to build a grid map where each cell measured 5 square centimeters. The real map has an area of 27.7 square meters, while the simulated map is about 8.2% larger, with an area of 29.99 square meters. This difference is due to some missing obstacles in the simulation and the lack of errors in the simulated lidar. To evaluate the person detection skill, we trained the YOLO4 object classifier using COCO and the Fallen Person Dataset, or FPDS. Specifically, we used the official YOLO model, which is trained on COCO, and then trained the network using FPDS train and test subsets for 7,000 epochs. For this experiment, we used the OpenVINO implementation of YOLO4. Tests with the FPDS validation set show that the retrained model achieves better average precision, and recall. Our preliminary results indicate that the digital twins adequately recreate the real environment. We successfully deployed Cartographer to perform simultaneous localization and mapping, or SLAM, in both real and virtual environments using the same set of parameters. The robot was also able to navigate the environment towards a goal. The gesture detection provided by Oculus Quest 2 enabled us to test human-robot interaction with more dynamic and diverse movements than those provided by predefined animations. Regarding fall detection, the use of a virtual avatar will speed up the evaluation of the fall detection system, since we can simulate scenarios that would not be safe in the real world. We were able to save time and cost associated with real-world testing, which includes planning time, setup time, travel time, test execution, and test data recording. There is also potential for accelerated and automated test cycles and automated analysis of the mean time between failures. Currently, the simulator faces limitations regarding the accuracy of the sensor models. At this point, we are adopting a Gaussian error model for the LiDAR and RGBD camera, similar to the model found in Gazebo. In future works, we will employ an error model that closely resembles the real sensor. Here, we present our preliminary results using digital twins for understanding how virtual robot navigation and fall detection can be tested employing VR simulation. It allowed us to overcome the COVID-19 restrictions that impede access to long-term care facilities. We fine-tuned the parameters of Cartographer and MoveBase to improve Ether's navigation. We replaced the Unity Sensor SDK with our own implementation of the sensor, and were able to improve the performance of the simulator without sacrificing accuracy. We also successfully used YOLO4 to detect people and objects inside the virtual environment. Future work will focus on producing a synthetic data set for improving YOLO4 detection of falling people. We will also introduce new categories of objects commonly found in long-term care facilities, such as wheelchairs, canes, and walkers. Finally, we will investigate full body tracking to test various human-robot interactions. Thank you for watching this presentation to the end. You can contact us at ether@3srp.com and find more information at 3srp.com. We thank the financial support of Mitex, Agewell, JDQ Systems Incorporated, and the Developmental Disabilities Association.